What must a mathematical equation have to be considered a quadratic function? No, it needn't have any numbers. What must it have? It must have two variables, an independent and a dependent variable, which we will always use, unless we're doing a physics question, will always be x and y. But what would make it a quadratic? Thank goodness. Sarah? One of the variables has to be squared. Now, for our purposes in grade 11, it's the independent variable that is squared. Okay? So a quadratic function at its very, very most basic has this form. Okay? That's the very basic one. Now, we've been working with quadratics in this form. Correct? That's what we're used to seeing. ABC, we can put it in the quadratic formula, we can work with it. Or we can factor it, or we can complete the square, yes? Okay. This is standard form. And it has its uses, but there are two other forms. We're going to get to them as we get to them, okay? But first we're going to start with this. Now, if I were to ask you to graph an equation, think back to the 9th grade, before you learn slope-intercept form, before you learn point-slope form. Back in the 9th grade, how did you graph an equation? What did you use? Back in the 9th grade, if I gave you this, y equaled x plus 3, what would you have done if I said graph that? You would have made a t-chart or a table of values, depending on what your teacher called it, right? So let's do that for a parabola now. Nothing changes, x, y. But because it's a parabola instead of a line, we're going to use 5 points instead of 3 points. Everybody okay with that? And we're going to use -2, -1, 0, 1, and 2. So when x is -2, what goes there? -2. And then I will square that, which is what? 4. So when x is -2, my y value is 4. Agreed? Okay. When x is -1, what's my y value? +1. When x is 0, what's my y value? 0. When x is 1, what's my y value? 1. And when x is 2, what's my y value? 4. So 0, 0, right there. Agreed? Over 1, up 1, 1, 1. Agreed? Over 2, now up 1, 2, 3, 4. And I get this curve now. Everybody cool? Now let's look at this curve for a moment. Because while it is not like a line, and it is not constant, it does have a pattern. From 0, 0, this point right here, which is the vertex, so you should label it. From the vertex, the next point over was how far this way? 1. And how far up? 1. Everyone agree? I went over 1, up 1, yeah? Now, if it were a straight line, the next point would be over 1, up 1, yes? But it's not a straight line. How far did I go to get to the second point? 2. And how far up did I go? 4. Everybody see that? Now, if something happens twice in math, how often does it happen? Always. So over 1, up 1, over 2, up 4. What's the relationship between 2 and 4? 2 squared is 4, yes? So logically, if I go over 3 from here, where's the next point going to be? 9. Yes? X squared. If I go over 4, how far up? 16. If I go over 5, how far up? 25. And so on and so on and so on. And the same thing happens on the other side. Everybody understand? Everyone's cool? Okay. So, all quadratics have this pattern. Okay? If they are in a regular form. All right? And it is very simple. They all go from the vertex, and the vertex, we remember, is right now it's the lowest point, yes? But parabolas can turn. This is still a parabola. Okay? So I don't like to say the lowest point. I like to say the vertex is where the curve turns back. Okay? Now in grade 11, all of our parabolas are going to be that or that. So the vertex is there or there. Everybody cool? Now in grade 12, parabolas can go sideways. In university, they can go diagonally. Okay? But for our purposes, they're either going to be up or down. Everybody good? Okay. And they all follow this pattern. Point 1 is 1 right and 1 up. Now, that's if it's this kind of parabola. What if it's the red kind of parabola? Then where's this one going to be? Down. So it's either going to, I should have used green. It's 1 right or left, because it goes on both sides. And then if it's the green parabola, it's 1 up. And if it's the red parabola, it's 1 down. Everybody cool? Where will the second point be? It will be 2 right or left from the vertex. And then what? If it's a green parabola, it will be 4 up. And if it's the red parabola, it will be 4 down. And so on and so on and so on. Right? The up and down is always the square of the left and right. Everybody cool? Easy peasy, right? Okay. So now we got to talk about what a parabola actually looks like. These are the 6 properties that we have to be comfortable with. We've already talked about the vertex, yes? In grade 11, the vertex is always the highest or lowest point on which axis? On the y-axis. Always. All right? If it's a red parabola, it would look like this. Right? Somewhere through the y-axis. Cool? And if it was a green parabola, it would look like that. And there with the vertex. Everybody okay? In the red parabola, the vertex is the highest point, yes? So this vertex is a maximum. Because there's no y values bigger than the vertex. So logically, what does that make this one? A minimum. I know the screen's blue. I'll fix it in a sec. Pause. Get it? Unless you have a VCR and then it's this. But none of you have VCRs anymore, so it's not funny. Do you actually use it ever? Shut up your face. I'm like 150. I have 3 VCRs in the house. I never use them. They didn't get the DVDs? What?
It's from my great-grandma.
Oh. All right. Okay, so, ladies and gentlemen, we are working with the most basic parabola available to us. What is the vertex of this parabola? We just graphed it. 0, 0. Remember, a vertex has an x and a y value. Yeah, yeah? Yeah, yeah. Okay. The next thing we have to talk about is the axis of symmetry. Now, depending on who your grade 9 teacher was, you maybe did some work with symmetry. You maybe did it in grade 7, maybe did it in grade 6. Your teacher might have given you this little red piece of plastic, put it on the paper, and you draw something, and it's the reflection of the other side. You remember doing that? Right? They would give you a shape like this, and you'd put this red thing on the paper, and it would reflect that over here, and you'd be able to draw it. Anybody remember that? A couple of people have done it, right? We all know what symmetry means. It's when things are the same on both halves. Now, there's all kinds of symmetry, right? A human face basically has vertical symmetry, right? Basically. It's not real. It's actually kind of creepy when you use a computer and you cut a picture in half and you rotate this side of the face over here. Faces look weird when you actually make them symmetrical. You're like, ugh, because they don't look right. But for our illustrative purposes, everybody understands that we have symmetry this way, yes? Do we have vertical symmetry? No, because our head is not at our feet. If you fold us in half at our waist, the halves are different. Everybody cool? So in grade 11, our parabolas are all vertical U's, yes? So they have symmetry right down the middle, right? So the axis of symmetry is the imaginary vertical line. Spell it right, idiot. Vertical line through the vertex. And why is it important? You don't have to write this down, but notice, if I have a point here, one to the right and one up, that point has to exist over here. It's got the same y value, but at the opposite x value. Everybody with me? Same thing up here. Cool? Okay. So that's what the axis of symmetry is. But the equation of the axis of symmetry is x equals a number. And that number is the x in the vertex. Everybody cool? So in our most easy parabola ever, the axis of symmetry is x equals 0. And what do I mean by that? This line right here is the imaginary vertical line through the axis. And that line's value is x equals 0. Because for every point on that line, the x coordinate will be 0. Everybody with me? Also something from grade 9 and 10. X-intercepts. We know what those are from grade 9 and 10. X-intercepts are... Oh, this is my wife calling, which probably means her mother has died. Give me a moment.
Yeah, man, that'd be so sad if it was true. I'm sure it's always big.
I didn't think why you spend so much time on it?
That's a lot of time. That's like when what was he? Like I can explain 3 questions during that time. I'm talking about physics.
Indeed. That is what has happened. So, I will finish this class, though, because nothing can be done. All right. Give me a moment to collect myself. What was I saying?
You're talking about the...
X-intercepts. All right. Every X-intercept we know has an X value, and what's its Y value? The screen is blue. Every X-intercept, though, whether the screen is blue or not, we know has a Y value of what? 0. That's back from grade 10, right? On a straight line. We have been using these. We are calling these the roots. Unless we're using our graphing calculator, and then what do we call it on that? The zeros. Right? Everyone is good? On a graph, the x-intercepts are where the parabola touches the x-axis. And what are our 3 options? It can touch twice, 2 roots. It can touch once, 1 root. Or it can touch 0 times, which is 0 roots. Everybody good? Now, you don't need to write this down. How many roots on that one? 2. There and there. How many roots on that one? 1. How many roots on that one? None. Everybody cool? Okay. So in our most basic, easiest parabola, how many roots does this one have? 1 root at what point? At 0, 0. Because every point on the graph has 2 coordinates. Everybody still cool? Okay. The y-intercept, what's that? Zero y, and that's what it is in algebra. What is it in an actual graph? What is it? When the parabola touches the y-axis. How many can there be in grade 10, in grade 11? One only. A parabola will always touch the y-axis. How many times? In grade 11, once. And again, you don't have to write this down. I just want to prove it to you. Oops. Oh, well, we'll do it on its own page. Here is a Cartesian plane, yes? Here is a grade 11 parabola. Does that parabola touch the y-axis on the screen? No. But what is happening to this parabola? It's going to spread out and out and out, right? Eventually, what's going to happen? This side of it will touch the y-axis. Will this side ever? No. If I turn the parabola over and do this parabola, does that touch it? No. But as it keeps going, it will eventually. Will this side ever? No. So in grade 11, there will always be one y-intercept. Now in grade 12 and further, parabolas will turn this way, in which case there is only one x-intercept, but two y-intercepts. Everybody cool? But we only care about the vertical ones. So again, in our easiest parabola ever, what is the y-intercept? Where's the only place it crosses the y-axis? At 0. And since it's a coordinate on it's a point on the coordinate grid, we give it both points. Everybody's cool? All right. Now, grade 10. What's the domain? Can anybody remember what domain means in grade 10? From grade 10. I'm holding back my tears, not because of what's going on in my life, but because I taught every single one of you grade 10, except for 3 of you. We spent like 8 days on domain.
Just on domain.
It's the danger, Will Robinson, danger! From old Lost in Space, not the cool-ass new Netflix one, where the robot is so badass. If you haven't watched Lost in Space, watch it soon, because the second season is coming out. And the first season kicked ass. Well, spoiler alert, they did indeed get lost in space. But, you know, that's kind of like saying the guy in Breaking Bad broke badly. There's a spoiler alert in a lot of titles. Oh, yeah, you're getting warm. Okay, obviously we have to cover this again. The domain are the set of input values. Now, the input values in reality are the IV values, the independent variable. Now, in this class, because we're only talking about x's and y's right now, they are the x values. Now, if we were doing a physics question, distance and time or height and time, then the domain would be time, because that's the independent variable. Everyone cool? All right. So, again, think of our parabolas. Again, you do not need to draw this. But this black parabola here, what is going to happen to it as it approaches infinity? What is going to happen to this distance? It's going to get wider and wider and wider and wider. Will this parabola ever stop expanding this way? So will it cover all of those x's? Till when? Infinity. Will it cover all of those negative x's? till when? Infinity. So in math class, the domain of a parabola is x, and then you remember that funky e? X is a set of real numbers. Because it is all the x's. Because no matter what, in our easiest parabola ever, y equals x squared, can I put any number in for x? Yes. Because I can always square it. So this is math class. In reality, if we had a parabolic function that we were graphing of something happening in real life, would that be the domain? No, of course not, because we couldn't have negative time, could we? Or something like that. So in math, it's that. In reality, and I wanted to change the color there, in reality, the domain is restricted. Everybody cool? For example, if I was counting population growth, we've all seen graphs of population growth. It's not a straight line, is it? It's always a curve, right? That population will not get to infinity, will it? And it could never be negative. And it also could never be partial, could it? We don't count population 35 million and a half people, do we? So there's restrictions on the domain in reality. Now you're intelligent young people. If the domain are the x's, what are the range? The y's, right? So they are the set of output values, the dv values, and in grade 11, they're the y values. Everybody cool? Now, again, you don't have to write this down, just think. Where are their y values on this parabola? Where do they start? At the vertex. Right there. And where do they go? Forever in what direction? In this case, only what? Up. Will there ever be a y value lower than the vertex? No. So the range is always, the y is always, range is greater than the y of the vertex if the vertex is a minimum. Oh, sorry, that was the green parabola. I'm sorry, guys. My brain is obviously not totally functioning. This type of parabola, because that vertex is a minimum, so the range has to be greater than that y. And then the range must be less than the y vertex if the vertex is a maximum, which is that one. Is everybody cool? Now, in reality, those y values go till what? Positive infinity or negative infinity, right? In math. In reality, they would be restricted. Is everybody good? Yeah? Sweet! Okay. Let's turn the page over. And remember, we are comfortable with this. Correct? So everybody take that and graph it right here. We're not going to use a graphing calculator. We're going to use our brains. So starting from here, we've already graphed it. We know it starts at 0, 0. Where's the next point? 1 right, 1 up. 1, 1. And because it's there and it reflects, there's another one there. Everyone agrees, right? Where's the third and fourth points? 2 over and 4 up. So this is 1, 1. This is 2, 4. Agreed? And then this is the reflection of the x, negative 1, with the same y value. And what is this one going to be? Negative 2 and 4. And we get the easiest parabola ever. Yes? Okay. Now, we're going to build on that knowledge. We're going to start here. Everybody cool? Now, if I asked you to graph this, what would you do? You'd make a T-chart, right? And we'd put some points in. We choose the points, don't we? Okay, so let's take negative 5, negative 4, negative 3, negative 2, and negative 1. I chose those on purpose. You're going to see why in a second. What is negative 5 plus 3? And negative 2 squared is what? 4. What is negative 4 plus 3? 1, and 1 squared is 1. What is negative 3 plus 3? Squared? 0. Negative 2 plus 3? 1 squared is 1, and negative 1 plus 3? Squared? 4. What do you notice? There, 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 and there, 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 and there. They're the same numbers, right? What do you see there? A vertex. Because all of my y's are bigger than 0, yes? So my vertex is at negative 1, 2, 3. Negative 3, 0. And then, from the vertex, 1 over, 1 up. Negative 2, up 1. And then it reflects over here. Then I go to negative 1, up 4. And then it reflects over here. So what is the connection between our original parabola, the easiest one in the world, and this one? What happened to it? It shifted. What direction? Left. Plus 3. Now notice up here, isn't this part of vertex form that? So P is the shift, isn't it? That is our shift. Now, what does a negative mean? It means a lot of things in math. What are some of the things that symbol means? Decreasing. What else? Less. What else? Take away. Subtract. There's a ton of things that symbol means, yes? What does that symbol mean if I use it this way? 3 and negative 3. What would you call those two numbers? Opposites. So I do opposite whatever P is. So I'm supposed to opposite P. P is positive 3. So I don't move it positive 3. I move it negative 3. Just like in factoring, when we had x plus 3 equals 0, what's our actual answer? Negative 3. Everybody cool? Yeah? Okay. So that means all of you, without thinking about it, should be able to graph this guy. What would you do if that 2 wasn't there? It would be that, right? It's same as up here, yeah? But that 2 is there. So what do I do? I move it 2 to the right. So my vertex becomes what? Becomes 0, 2. And what is my first point? No, not 0, 2. 2, 0. 2, 0. And what is my first point? 3, 1. Over 1, up 1. What is this point here? 1, 1. Is everybody cool? We're all good? Okay. Now, that's the first thing we've changed. Now, if this wasn't there, that -4, we'd have this, right? Everyone agree? Okay. So, if I were to graph this, I'm going to use my x's, I'm going to use my y's. I'm going to use x, 1, 0, and -1. I only need 3 points. What is 1 squared? 1 minus 4? -3. What is 0 squared? 0 minus 4? What is -1 squared? Minus 4? -3. Where is the vertex? 0 and -4, correct? What is my vertex in the original easiest in the world parabola? 0, 0. What's my new vertex? -4. So what happened to my parabola? Did the x change? Just the y changed. How? It went down 4. So what is my new vertex? 0, -4. What's my first point? Over 1, up 1 to get 1, -3. And same y value, -3. Reflect the x value, -1. Everybody cool? So now we've covered this shift, haven't we? This shift was opposite because of the negative sign. What's that shift? Normal. So this shift is normal. So I saw -4. So since it's normal, I drop it 4. Everybody cool? All right. Now look at this question. Are both shifts on? Okay. So if this wasn't there and this wasn't there, I'd have this parabola, yes? But I have 2 shifts. What direction will that move the vertex? 2 to the right. Agreed? So it's going to go 2 to the right. What direction will that move the vertex? 5 up. Just like here, right? So what does that make my vertex now? Makes it 2, 5. Now notice the question gives it to me, doesn't it? Opposite of what I see, 2, and what I see, 5. What are these 2 points? The first 2 points. What's that one going to be? 3, 6. What's that one going to be? 1, 6. Y stay the same. X's have to change. Is everybody cool? Yeah? Okay, without me now, you graph this guy however you want. and show me the 2 points, the first 2 points on both sides of the vertex, please. So what's the vertex? Who's willing to take a guess? -2, 3. So I go over to -2 and I go up 3. There's my vertex. And the graph will go like this, yes? What are those first 2 points? What's this one? -1, 4. What's this one? -3, 4. Is everybody cool? It's really easy, right? It's just counting. Everyone's good? Okay. What's weird about this one? There's a negative in front of the x. Now, you're all intelligent people. Have we seen a negative in front of any x's? In front of any x's on this page? Look at the page. Have we? And every parabola we've drawn has looked like this, yes? So what must a negative x do? It's the upside down one. Or as some math teachers like to call it, the sad parabola. Because it goes like this. I am not that teacher. Okay? It's a negative parabola. Right? Do you think anything else changes? Instead of going one right and one up, where do I go? One right and one down. So what is that point right there? 1, -1. What's that point right there? -1, -1. So now all you should be able to graph this, yes? What's the vertex? Five, 6. Opposite, same. 5, 6. What's that negative mean? I don't go up, I go down. So it's going to go like this, right? What's that first point going to be? 4. What, Sarah? 4, 5. What's that point going to be? 6, 5. Y's stay the same across. X's are what changes. Is everybody cool? Now you're all, again, I keep telling you, even though you don't believe me, you're all very intelligent people. We've covered this shift. We've covered this shift. We've put a negative in front. What's the only other thing we could do? What's the only other thing I could put there? Say it loud. A number. Turn the page over. There's a number out in front. Now, as always, when we're in doubt and your teacher says graph, what is the thing that always works? Sip it. What is the thing that always works? -2, -1, 0, 1, 2. What is -2 squared? 4. And then what am I doing? Multiplying by 2. So what is it? 8. What's -1 squared? Times 2. 2. What's 0 squared? Times 2. 0. What's 1 squared? We already know this is going to be 2 and 8, don't we? All right. Remember, our original parabola, over 1, up 1, yes? Okay. Notice we have the same vertex, yes? But when I go over 1, how far up did I go? Over 1, up 2. So that point is 1, 2. What's this point? negative 1, 2. Then in the original parabola, when I go over 2, I went up 4, yes? How far did I go up this time? 8. What's the relation? It's doubled because there's a 2 in front. So every y stretch is doubled. Now you're intelligent young people. If a 2 doubles it, what will a 3 do? Triple it. What will a 4 do? Quadruple it. What will a 10 do? Multiply it by 10. So I will go over 1 and up. How far? 10. Over 2 and up. 40. Everybody good? Great. Now, again, very intelligent young people. If that's not there, what does our graph do? No, that's out by itself. It would go down 4, yes? All right. But that is there. If a 2 doubles it, what will a half do? Half it. So I would go over 1 and up half. Over 2 and up 2 instead of 4. Everybody with me? So my new vertex changes. Where is it now? It drops 4. There's my vertex. 0, negative 4. Yes? Everybody cool? Okay. If I move 1 to the right, how far up will I go? Half. That's a pain in the ass, isn't it? So we're going to skip that point. We're going to go over 2. And how far up will we go? 2. So what's the next point on our graph? Over 2. Up 2. What is that? 2. Negative 2. And what's this one? Negative 2, 2. Everybody cool? Yeah, negative 2, negative 2. Everybody cool? So, notice, if this number is bigger than 1, when a is greater than 1, our parabolas get skinny because they're stretching upwards. When a is between, I'll change colors. When a is between 0 and 1, our parabola stretches this way because the stretch up is being fractioned. Does everybody understand? Okay, prove it. Graph this one, no tables of values. Using your brains, tell me 5 points from the graph. I want the vertex, the first 2, and the second 2. Go. I do know, man. Start from a vertex because you can get it right from the equation. Who's going to tell me the vertex? Everyone should be volunteering now because that's the easy one, right? So if you volunteer now and I call on you, I probably won't call on you again. What's the vertex? 2, 6. 2, 6. What kind of parabola is it? Happy or sad? Sad parabola. Why? Because it's negative, and negative is sad. We're positive people because we live in North America and everything's awesome, right? Right. Because we're all going to be rich as soon as we leave high school. Yep. So, what is my first point? 1, 3. Because it should have been 1, 5, but it's been stretched by 3. So what's my second point? He waited patiently. 3, 3. What's my 1, 2, 3, fourth point? 0 and what? -3. Is that correct? It should have been over 2 and down how far? 4, right? But that 4 has been tripled. So it should have been over 2 and down 12. So it shouldn't be -3. What should it be? I got to do 6 minus 12, which is -6. 0, -6. And what will this point over here be? 4, -6. Everybody good? And it's a long, skinny, sad parabola. Everybody okay? All right, now, because I love you as if you were my own, we will put all of the rules in this spot in one handy-dandy little space. Okay? And I'll use a different color for each one. A. The y values multiply by a. So, in a normal parabola, it's 1 over 1 up, 2 over 4 up, 3 over 9 up. As soon as you see an A, all of these numbers, it's 1A, 4A, 9A. Everybody understand? If it's a negative A, it's not going to go up 9 times A, it's going to go down 9 times A. Everybody good? Meaning know that you haven't written down or know that you are lost, you've completely lost the plot. Okay. Everybody's with me? Yeah? Even Jack? What did P do? Right? It moved what? The x value of what? Move the x value of the vertex. How? That's what it does. It moves the x value of the vertex. And what does it actually mean? It means the vertex slides along the x-axis. And what's special that we have to remember? Opposite the sign in the equation. Now, I am going to highlight that opposite the sign in the equation. So, x plus 3, the vertex slides left 3. X minus 4, the vertex slides right 4. Is everybody cool? Next letter, Q. What does Q do for us? Moved the Y value of the vertex. The vertex slides along the y-axis the same as the sign in the equation. And I'm going to highlight the same. So if it is x squared plus 4, it's going to go up 4. If it is x squared minus 7, it is going to go down 7. Is everybody cool? We all good? Okay, I'm done. Class goes for 15 more minutes. I'm obviously going to leave. I got to go talk to the office and try and get out of here and have somebody cover my last class. If I'm not back before the bell rings, you're dismissed. And I might not be here, obviously, tomorrow. My wife's sad. I want to be a supportive husband. So if I am not here tomorrow, I want that practice test done. And I want the rest of whatever page we're on, 96, 97, 98, 99, 96 to 99 done. Everybody cool? Practice test, and 96 to 99. Now, we've already gone over the cumulative, right? Okay. So everyone's cool? All right. I don't know. I may see you tomorrow. I may not. Okay? But that should be enough work, yes? With 10 minutes now, because not many people did the practice test, that should get you through the period tomorrow, right? Okay. If you get done, please don't be horrible to the sub, because I'm not going to leave more than that. I'm not going to go home with everybody sad and plan a whole lesson for tomorrow, okay? So please, I know who's going to do what. I know who's going to sit with whom. I know what you're going to talk about. Don't drive the sub crazy. Don't throw crap around. Don't be like a TV show class from a TV show in the 70s. Okay? Just chill. All right? Okay.